In this video, we're going to use one trig value to find others. Before we do that, let me show you a shortcut of finding the values of trig functions when degree is 0, 30, 45, 60, and 90. So if you want to find the sign of 0, 30, 45, 60, 90, this is the pattern that you want to follow. Start from 0, 1, 2, 3, and 4, and put radicals. And then divide each one by 2. Now, you know that this is the same thing as 0. That means sine of 0 will be 0. Sine of 30 will be 1/2. Sine of 45 is radical 2 over 2, and so forth. And notice sine of 90 is going to be 1. For cosine theta, what you want to do is, instead of starting from 0, you want to start from 4 and go down. And then put radical, and then divide by 2. So this means that cosine of 0 is 1. Cosine of 30 is radical 2 over 2, and so forth. Now, how do you find tangent theta? Well, tangent theta is sine theta over cosine theta. So 0 divided by 1 is 0. And 1 over 2 divided by radical 3 over 2 will be 1 over, you'll be 1 over radical 3. But you know that 1 over radical 3 is the same thing as radical 3 over 3. And when you divide radical 2 over 2 divided by radical 2 over 2, it's going to be 1. What about radical 3 over 2 divided by 1 over 2? It'll be radical 3. And finally, 1 divided by 0 is undefined, because you cannot have a denominator as 0. So tangent of 90 is undefined. So this is a nice way of memorizing trig functions when degree is 0, 30, 45, 60, and 90. Some of you might wonder, how do you find cosecant theta, secant theta, and cotangent theta? Remember, cosecant theta is just a reciprocal of sine theta, and secant theta is a reciprocal cosine theta, and cotangent theta is a reciprocal of tangent theta. In quadrant 1, all the 6 trig functions will be positive because both x and y are positive. In second quadrant, however, only sine theta and the reciprocal of sine theta, which is cosecant theta, will be positive. All the others will be negative because in second quadrant, x is negative and y value is positive, where in first quadrant, they're both positive. In the third quadrant, both x and y are negatives. Therefore, only the tangent and the reciprocal of tangent, which is cotangent theta, is positive, and all the others will be negative. In the fourth quadrant, x is positive and y is negative. Therefore, only the cosine theta and the reciprocal, which is secant theta, is positive. All the others will be negative. There is another way of looking at this. I'm going to use acronym. All students take calculus. All students take calculus. This means in first quadrant, all 6 trig functions will be positive. In second quadrant, only sine and the reciprocal of sine, which is cosecant theta, is positive. In third quadrant, tangent, and its reciprocal is positive. All the others are negative. In the fourth quadrant, C, cosine, and its reciprocal is positive, and all the others will be negative. It says let tangent theta equals 5 over 12, where sine theta is less than 0. That means sine theta is negative. They want us to find exact values of 5 remaining trig functions of theta. So we first need to find in which quadrant that these two occur, where tangent theta is positive and sine is negative. Remember, all students take calculus. In first quadrant, all 6 trig functions are positive, so this cannot happen because sine has to be negative. In second quadrant, only the sine and cosecant are positive. So this is not true either because we want the sine to be negative. In the third quadrant, tangent is positive, and also sine is negative. So this happens in the third quadrant. And in the third quadrant, since tangent theta is y over x, y will be negative 5 and x will be negative 12. Since negative divided by negative is positive. And in the third quadrant, both x and y are negatives. So we have x equals negative 12, y equals negative 5. And we need to find r. And what is r? R is going to be square root of x squared plus y squared. And this becomes 144 plus 25, which is radical 169, and that's 13. So we know that r is 13. Now using these 3 information, we could find sine theta is y over r, which is negative 5 over 13. Cosine theta is x over r, which is negative 12 over 13. Now notice, sine is negative because the theta is in the third quadrant. Cosine is negative because the theta is in the third quadrant as well. Now tangent theta was given. That's 5 over 12. Now what about cosecant theta? It's the reciprocal of sine theta. So negative 13 over 5. Secant theta is negative 13 over 12. And finally, cotangent theta is 12 over 5. Now, what if they say secant theta equals radical 3 and tangent theta is less than 0, which means that tangent theta has to be negative and secant theta has to be positive. So in which quadrant does this occur? Well, first of all, in first quadrant, all students take calculus, so everything is positive first. So this cannot happen in first quadrant because tangent has to be negative. And you know that tangent is negative either in second or fourth. Because in third quadrant, tangent is positive. So now, when is secant theta positive? Secant theta is positive only in first and fourth. So this could only happen in the fourth quadrant. And we know that secant theta is r over x. And notice we could rewrite radical 3 as radical 3 over 1. So this means r is equal to radical 3 and x is equal to 1. And we need to find the value of y in the fourth quadrant. So basically we have a triangle that looks like this, something like this, where r is radical 3, and x is 1, and we got to find the value of y here. We know that r is square root of x squared plus y squared. So r, which is radical 3, is equal to square root of 1 squared plus y squared, and we need to find the value of y. So let's square both sides. Then you are going to get rid of the radical. 3 equals 1 plus y squared. So 2 equals y squared, and y is positive negative radical 2. Since this is the fourth quadrant, okay, the distance is always positive. You know that this point right here has to be 1 comma negative radical 2. Why? Because this point is in the fourth quadrant. In the fourth quadrant, x is positive, y is negative. Therefore, y is negative radical 2. And we have r, x, and y, so we could find the rest of the trig functions. So sine theta is y over r, which is negative radical 2 over radical 3, which is going to be multiplied by radical 3 top and bottom. You'll get negative radical 6 over 3. What about cosine theta? It's x over r, 1 over radical 3, multiply top and bottom by radical 3. You'll get radical 3 over 3. Now tangent theta is y over x, so negative radical 2 over 1, which is negative radical 2. How are you going to find cosecant theta? Cosecant theta is reciprocal of sine theta, or just the r over y. So it's going to be radical 3 over negative radical 2, which is going to be multiplied top and bottom by radical 2. You'll get negative radical 6 over 2. And we already have a secant theta. It was given, so we don't need to find that. Finally, we need to find cotangent theta. Cotangent theta is x over y, or the reciprocal of tangent theta. Multiply top and bottom by radical 2, you get negative radical 2 over 2. So we found all the 6 trig functions.